Now here we go. Connection between them. Earlier, not the last video, the one before it, we said the arc length S, which is R times theta. And really that lets you know the relationship between the linear distance versus the angular distance or position. The linear position versus the angular position. S, which is how long we took that piece of paper. If you take, again, a portion of this, if you take a third of a turn from here to here, what's the arc length? Well, the arc length of that, it depends on the radius, and it depends on the angle. The angle is 1/3 of a circle. That's 2 pi over 3 multiplied by the radius. So there is a relationship between the angular position and the linear position. This is your linear position, that's your angular position. We also have another one that ties the angular speed to the linear speed. V equals R times W. We mentioned that one early too. How fast the wheel is spinning on a bicycle will determine how fast the bike is moving on that road. Two things, R and W, will determine how fast you're going to be moving. And the linear and angular acceleration, which says A equals R times alpha. These are the three things that actually we mentioned earlier. So that's the relationship between them. And I'm going to do some examples using these. Okay. If you go on a merry-go-round, which is, you get a couple of people, one person sitting here, one person sitting there farther. We have two people on the merry-go-round. So this is number 1 and this is number 2. And the first one, can you tell me, as this one starts to spin, is the angular speed for one bigger or smaller than number 2 or equal to? The angular speed. The angular speed for the first person, is it bigger than the angular speed for the second one? Is it equal to? Is it less than, greater than? Which one? What is the relationship of W1 to W2? Your options: less than, greater than, or equal to. What do you think? The angular speed is how fast the wheel is turning. RPM. RPM is not affected where you're sitting on that piece. So for this, they have to be equal. The RPM for that wheel didn't change where you sit, here or there. The wheel's still going 20 revolutions per minute. Doesn't matter where you sit. What about V? The linear velocity for person 1 and the linear velocity for person 2. Are they the same? Is one bigger, less than, or equal to the linear velocity? Well, what's the velocity? Velocity depends on R and W. Did W change for either person? No. But did R change for them? Notice this is R for person 2 and this is R for person 1. V equals R times W. The bigger R is, the larger V is. So velocity 1, since W is the same for both, and R1 is bigger than R2, velocity 1 has to be greater than velocity 2. And what about the acceleration for 1 and 2? And what about W for 1 and 2? I mean, not W. Alpha for 1 and 2. I'll do alpha first. Jimbo.
Alpha's always first.
So alpha is really how fast the increase and decrease in the rotation. It doesn't matter where you sit. So these two will be equal to each other. Is the change in W. And W is the same for both them. But now alpha, or A, is R times alpha. So the bigger R is, the larger A is. So A1 has to be greater than A2. So when things spinning again in a circle like blood, centrifuge, when you go to the doctor, you start spinning to separate the blood, the plasmas. They spin them at high speed. Why? What happens? Just like the car making the turn on the track in the previous videos, we talked about them. What happens when things start to go in a circle, you have a centripetal force. Centripetal acceleration, centripetal force. The centripetal acceleration, if you remember, it's V squared over R. That's centripetal acceleration. And the centripetal force, it's mv squared over r. Newton's second law. Force equals mass times acceleration. So if we use these, wait a minute, let's replace v with r times w. Isn't v equals r times w? So if I do that, that equation will become rw squared divided by r, which is r squared w squared over r. And if you simplify the math, that's r times w squared. So if you know w and you know r, you know what the centripetal acceleration. If you know v and you know r, you know what the centripetal acceleration. So it depends what you know. Do you know v and r or w and r? If you know w and r, use that one. If you know v and r, use this one. Same thing, centripetal force. This is what the acceleration, so the force will be mass times acceleration. M times r times w squared. Because the acceleration is r times w squared from here. F equals ma. This is the acceleration multiplied by the mass, and that's your centripetal force. You can use either one. Let's do a centrifuge problem there. When I was young, I worked at the lab, collecting samples for a doctor, going back, bring them back, put them in the centrifuge, make sure they spin them, then I leave them for them to read them, you know. And usually when you put them in the centrifuge, you better balance it there. So you might have a tube here that has blood in it, and you'll have another one on this end that has blood in it there. And you might have one that's empty here, or just liquid. But you never put blood and leave this one empty. That's not good for it, just like a lawnmower. You want to make sure it's balanced. So the centrifuge spins at high speed. So this one spins at 11,500 RPM. 11,500 RPM. And the radius from the center to the edge of that centrifuge, because it's spinning like this, that radius here is just go 9 centimeters. It's good enough. 9.0. In the question, here we go, find the linear speed. That's the first one. 2, find the centrifugal acceleration. Again, we got a little problem. RPM is the speed, W in RPM there. We don't like the RPM. So what's W then? W is equal to 11,500 RPM. That's over 1. I need to convert that well, I can't do them in one shot, so let me do this. From revolution first, RPM will write like this, rev per minute. I don't think I have an RPM on my cheat sheet to meters per second. It might be actually. Do I have anything that does RPM to meters per rad per second? Doesn't look like, so I got to do it myself. Revolution per minute, that's what RPM. So 1 rev equal how many radian? 2 pi. Rev cancels rev. I had radian per minute. I don't want it per minute. I want it per second. So I want minute on the top, seconds on the bottom. 1 minute is 60 seconds. If you do the math, W is equal to what? 1,204 rad per second. Find the linear speed. What does that mean, linear speed? That means actually V, not W. W is the angular speed. Find V. Well, V equals R times W. V equals R times W. I know what R, I know what W is. R is what? R is 9 centimeters, that's 0.09 meters, and W 1204. .4 meters per second. What's the centrifugal acceleration? I can either use V squared over R, or I can use RW squared. Either one. Since I have both, either equation. I'll do it both ways just to show you the answer is the same. V is what? 108.4. Square it. Divided by R, which is 0.09. Or 0.09, that's what R is, times W, which is what? 1204 squared. Either way. $108.4 squared divided by 0.09. 130562. Or, if I use that equation, $130,465, and I'm sure that's just rounding errors because you're squaring that number. But if I carried all my digits, or if I use two significant digits, I'll be okay, because that's 1, 2, 3, 4, 5, 1.3 times 10 to the fifth, or 1.3 times 10 to the fifth. Even if I use three significant digits, I'll be a 1 here if I use three significant digits. But again, they're just rounding errors. Either equation should give you the same answer. One more example of these, then I'm done for today, unless you have questions for me. Let's take a car. Here's a car. The radius of the tire on the car is 32 centimeter. That's the radius. Drives on the highway at 55 miles per hour. That's the velocity, linear velocity. 55 miles per hour. What is the angular speed of the tire? So question number 1, find W. And the second question, B, what is V? What is the speed at the top of the tire? W is not bad. V is a little bit tricky there. Got to think about it at the top there. Let's look at W. Well, we know the linear velocity, V equals what? 55 miles per hour. I need to convert that to meters per second. One meter per second is what? 2.24 miles per hour? $55 divided by 2.24, 24.6. V equals what? R times W. R times W. R for this one is what? 0.32. V is what? 24.6. Can we get what W is? And I got roughly 77 rad per second. 76.7 or 77. Part B is a little bit tricky. You got to think about it. Here's what I'm looking at for the tire. The tire is turning, but if you watch it, let's say there's a spot in the middle of that tire, that's the center there. What you're seeing is that piece moving at a speed of 55 miles per hour. That's what you're seeing. If there's like a white dot of paint, and you're seeing the car going by, you look at that white dot of paint, you see that dot moving at 55 miles per hour. That's the speed of the car. The question is, what is the speed or the velocity up there, the linear velocity at the top there? What's that velocity at a point up there? Well, if you think about this now, if you look at it, if you see the wheel spinning around on the ground, turning on the ground, that point is actually how far from it? That's R, right? And what's that distance all the way up there? 2R. Yes, twice that number. So your velocity on the top, so the velocity in the middle here is R times W, and that's the 55 miles per hour that you're seeing. But the velocity on the top is going to be the distance, which is 2R times W, which is 2 times RW, and RW happens to be 55. 2 times the 55, which is 110 miles per hour. So the top of the tire is actually moving at 110 miles per hour, where the center of the tire is moving at 55 miles per hour. Linear velocity. Again, if you take a little string, 2 strings, one you attach it to the top of that tire on the top there, and it wraps around the tire as the tire goes by, and one in the center. You will see the one on the top, if you take like a little piece of paper you attach to it, moving much faster than this one, twice the speed of this one. Sometimes I take a bottle of soda or a bottle of water, can I borrow that? And I attach 2 strings. I attach one string to this and attach one string to the top. As I'm turning the ball, which one's going to move faster? And I take the string, they dangle there, and I put a piece of paper attached to each one to see them moving. You'll notice the one attached to this one is going to be moving much faster. Why? Because the radius is much bigger. The radius here twice that, so the velocity on the top will be twice this velocity. Will be 110 miles per hour instead of 55 miles per hour.